Hello everyone and welcome to another SQL series with Learn at Knowstar. In today's session, we are going to take a look at a scenario in which we are going to generate a two-digit alphabetic series or sequence. So the sequence would look something like starting with A, B, AC, AD all the way down till AZ, and then it would cycle to BA, BB, BC, BD and so on, and the very last point of a sequence is going to be ZZ or Z. So we are going to generate this sequence. Now, to generate this sequence, the very first step for us is going to be to generate a series of numbers that we can utilize to count till the 26 alphabets that we have in the alphabetic series. So to do that, we are going to make use of some of our system tables. So if you have SQL Server installed, you would have some system databases installed by default. And if you go to the master databases and if you go to the system views, you will be able to find that there are some views starting with sys.columns, sys.objects or any of these views which we can utilize to generate a sequence of numbers. So how we can do that before we generate a series of numbers, let's just take a quick look at what is inside these tables. So these are nothing but system views or system tables which have some system related information which we are not concerned with. The only purpose of our using these system views is to generate a continuous series of numbers. So the way we can generate a continuous series of numbers using any of these system tables is to create a CTE which we can then use. So we can reference the column from the CTE and make use of the sequence that we generate over here. So let's call this CTE alphabet underscore CTE for our purpose because that is a requirement that we are working on. And what we're going to do is nothing but generate a row number column. So select row number. And since we are using an aggregate function, we have to use the over clause. So we are going to order by any one ID column from these tables. So let it be, let's say, object ID. And we are going to give this some name. So let's call is ALP just for the alphabetic series. And the table that we're going to use is sys.columns. And we can just close this over here. And we have this created, we have the CTE created. So if we just run this particular command from here, we can see that a series of numbers has been generated, which is a continuous series of number that is as per requirement. So 1, 2, 3, 4, that is what we want. Now you can take a look down here at the number of records that have been generated. So for now 1017 records have been generated and our requirement is only to have 676 records. So that is okay for us. That is more than our requirement. So we can go with this system tables. If your requirement is of some records which should be greater than, let's say, 1000 records, then you can check any of these tables and find out which table has large volume of records and you can replace the sys.columns by that table over here. So now since we have the series generated and we have put it within an CTE which we can use in our SQL query that we are going to frame to generate the alphabetic series. So before doing that, let's first understand how do we generate a series. So what is the logic behind that? So we are going to go back to an Excel sheet and take a look at how the logic can be written to generate a cyclic order of alphabetic digits. So if we take a closer look over here, we can see that we start with AA and go all the way down. So if we scroll down, you would see we will go till AZ, and then this A should then cycle to B. So this A, the first digit, the first alphabetic digit should move on to B, and the cycle for the second digit should again start from A. and it should go all the way till Z, and when it reaches Z, it should again move on to the next alphabet, which is C, and the cycle for the second digit should start all over again, and this repeats till we go till ZZ. Now there should be two observations from this point. The first observation is that the whole cycle combined of the two digits repeats after every 26 occurrences of these digits. So after every 26 runs or every 26 records, we have to change the series. So we have to change the first digit to move on to the next alphabet, and the second digit we have to trigger it to start the cycle all over again from A. And the next observation that we should have from this point is that with the combination of these two alphabetic characters, we have a total of 676 records, series records that can be generated. Until unless we want to cycle over again and start from AA, which is not what we're going to cover in this session, but that can be achieved as well with some modification of the SQL query that we are writing. Okay. So now that we have two observations, that there are 26 alphabets, we already know that there are 26 alphabets, and we have a cycle that should repeat after every 26 records that are generated in this series. So to generate this kind of cycle for 26 characters or for 1000 characters or whatever is a number on which we want to repeat the cycle, there are two mathematical formulas that we can use, and those are simple quotient and remainder. So when we are doing a division and we divide by these numbers which we have in one cycle, which for us is now 26 occurrences, then we get two parameters out of the division. One is the quotient and one is the remainder. So if we just calculate the quotient, let's say quotient and remainder over here. And now we are going to calculate the quotient based on the row number. Okay, so this is the row number that we have generated in a CTE table. So the first thing that I'm going to write is a formula to calculate the quotient. So in Excel, it is simply quotient, and I am going to divide my row number that I just generated. So this is going to be cell B2 for me, by the number of occurrences in my cycle. So the number of occurrences in my cycle is 26. So that is what I'm going to do. All right. Okay. And I'm just going to put this formula to all the alphabet, all the records that we have in this series. All right. So now let's calculate the remainder as well, and then we'll analyze the results and manipulate our formulas accordingly. So to calculate the remainder in Excel, there's a function called mod, and again I'm going to calculate it over my row number column, which is going to be B2, and I'm going to divide it by the number of occurrences in my cycle, which is going to be 26. So I divide it over here, and then I just propagate this formula all the way down till the very end of my series. All right. So now if we take a closer look, starting with the quotient, we can see that the quotient is 0. All right. It should be 0 till the, so it is 0 till the 25th row number. All right, and then it increases by 1 and so on. So it increases by 1, and it seems that it increases on every multiple of 26, it increases by 1. All right, so that is an analysis that we have. For the remainder, we can see that the remainder increases by 1 and it goes all the way till, let's say, 25. And then it starts for every multiple, complete perfect multiple of 26, it becomes 0. And then it again starts from 1, goes all the way till 25. And again it encounters a perfect multiple of 26 and becomes 0. Alright, so these are the analysis results, but we need to tweak them a little bit to be able to use them for our requirements. So what is a requirement? A requirement is that we want the first digit to remain and have a constant value of A till there are 26 rows, and then it moves on to the next alphabet, which is B, which again remains constant for the next 26 rows. So to have a constant for every 26 rows, we need a constant value over here of the quotient which we can utilize. Now what we have got right now is a constant value till the digit till the row number 25, but it changes on 26. That is not what we want, because for 26 row number as well, the first digit should remain as A. So what I'm going to do is make it constant for every 26 row numbers. So we are just going to add a -1 over here, and then let us re-propagate the formula, and let's check what we have got in the results. So now what has happened is that for the 26th row, also it has got a value of 0. So for every 26 rows, ideally it should have a constant value. So for the first 26, it has 0. Then till 52, it has 1, and so on. So now it's a constant value for every 26 digits. So what we have done, again, we have just subtracted a 1 from the row number. So now instead of dividing 1 by 26, what I'm doing is I'm subtracting a 1 minus 1, 0 by 26. Okay, so that when it encounters a perfect multiple of 26, which is the 26th row, it does not give me a 1. Instead, it makes it 26 minus 1, which is 25 divided by 26. That again gives me a 0. So this way, my value remains constant for every 26 records. All right. So that is somewhat what we needed for the first part of our alphabetic series. Now for the second part, a requirement is that the value should actually cycle for every 26 records. So it should go from A to Z, and as soon as it reaches a 26th record, it should cycle back from A. So it should start back from A and go all the way till Z, and so on. Now the results that we have got from the remainder right now are 1, 2, 3. Okay, that's okay. It changes. So we want actually incrementing values till the 26th row number. Now what is happening, again the same case is happening, that we have got incrementing values till the 25th row, and then it becomes 0. Now 0 is not of any use to us here. So what we are going to make it is, we are going to start the series from 0 instead of starting it from 1. So instead of having a B2 here, again the same thing I'm going to do. I'm just going to subtract a 1 so that my series now starts from 0. So it becomes 0 to 25. So I have a continuous series of 26 digits happening every time. So you can now see that on the 26th row, it goes till 25th value, and then it again starts from 0 and goes till 25th value for the second sequence or the second cycle of 26 alphabets, and then it again starts from 0 and so on. So now this is what we are going to use in our requirements. Now these are just numbers, right? We want alphabets in our requirement. So what we need basically is we want to convert these to equivalent alphabetic digits. So what we can do for that is that we can convert it to characters. We can treat these as ASCII or ASCII values, and then use these ASCII values to interpret characters from them. Now to do that, we should be aware that the ASCII value of A is 65, and it then increments by 1. So it becomes, for B it becomes 66, for C it becomes 67, and so on, and it goes till 90, which is the ASCII value of Z. So it is a range of 65 to 90. Now what we are going to do now is we are just going to convert these values that we calculated using the quotient and remainder formulas that we just created, and now I'm going to convert these ASCII values to character. But first I need to add 65 to these values, because the series, the alphabetic series, the ASCII values start from 65. So what I'm going to do is simply add 65 to these values and then create my series. So if I do that, all right, and increment it and go all the way down, you would see that I've got A created, all right, till the 26th row, and from the 27th it goes to B, and so on. And for the second digit, again, I'm going to do the same thing. I'm going to convert these values, treating them as ASCII values, and add just 65 to that, so that I have my series starting point for the alphabetic numbers. All right, so I'm just going to add 65 to the indexes that we just generated, and if you propagate it down, you would see that it goes till A, B, C, D, so it will cycle till Z. Okay, so where are we? All right, let's go down a little bit. It will cycle till Z. So this is the 52nd record, and then it starts from A and so on. So if you go to the 26th record, so it will be easier for you to understand. You can see that for the 26th row number, it goes till Z, and then it starts back from A. And if we go to the very last of our sequence, we should be able to see that this is ZZ, which is what we want. Now this is a logic basically that we need to implement in our SQL as well. All right, so simple. The same things we need to implement. We need to calculate the quotient and the remainder and then concatenate them together. So going back to the SQL, we have these row numbers already created. Now we are going to write a simple select statement. So select. All right, and now the first part for us was to calculate the quotient. Now to calculate the quotient in SQL, we can simply use the slash sign. Okay, that would calculate the quotient for us. So what we are going to do now is simply we are going to use this row number that we just generated. All right, subtract a 1 from it, so that the cycle repeats every 26 numbers and it doesn't reset on the 26th number. And then we are going to take a quotient, so simply use a forward slash and divide it by 26. And now whatever result that we are going to get, okay, whatever results we are going to get, we have to add, okay, let's put this again within brackets. We have to add 65 to it because we want the equivalent ASCII character for A, right? So we have to add 65 to this, and then we can convert this whole thing to character. All right, so the next thing that we want to have is the second part. So we are just going to add it. And for the second part, we have to now take the remainder. So to take the remainder, what we have to use over here, we have to first use the same logic. So we have to do else minus 1. And to get the remainder, we have to use the percent sign over here and divide it by 60, not 65, divided by 26. And then, okay, let's just put this all within brackets again. And we are going to add 65 to this. All right. And again, we are going to convert this whole to character. Okay. And we are just going to select this from the CD that we defined above. All right. So this is going to be our formula. Let's just run it and see. Okay, so this is because we have to add an as over here to define the CTE. And now if we run this, then we would get a sequence that you can see here. Now you can see that we are still getting 1017 rows. And if we scroll down to the bottom, you'll see that there are invalid characters and small cases of alphabets which have been generated. So we do not want that. We want to restrict it till 675. So we are going to add a where condition where is less than equal to 676. And now if we execute this query, we will get 670 rows. So let's just go down to the bottom row and you can see that this is ZZ correctly generated. If we go above AA, let's go to the 26th row. All right, so let's go to the 26th row. All right, so this is AZ, then BA, BB, BC, and so on. all the way till ZZ. So this is how you can generate an alphabetic series of numbers. There are obviously other ways of doing this as well, and you might have a requirement where you actually want to cycle over from ZZ back to AA as well. So there's also a link that has very interesting way of solving this challenge, and that is the link that you can find in the description box. Other than that, I hope that you found this video useful. If you have any questions or any comments, then please feel free to put them down in the comment section. Also, please do not forget to subscribe to our YouTube channel because we'll be posting many more videos on SQL. Thanks a lot for watching. Thank you and goodbye.